Hello, children, and welcome back to Chapter 2, Chemistry, Lesson 1, Part 2, Chemical Bonds. Just a reminder that as you're watching this lesson, you should be taking handwritten notes in your loose leaf binder or notebook, and be ready for a little quiz tomorrow when you come in. But remember, handwritten notes on this lesson. By the end of this lesson, you should be able to identify how compounds are different than the elements that make them up, and describe the two types of chemical bonds. You should also know all these key terms down here by the end. If you want to take a screenshot right now so you have them, that'd be cool. All right, so leaving off where we left off in the last video, we're going to be talking about compounds now. All right, now knowing compounds, to know compounds is important to know what elements are from the last video. Okay, now an element is the purest type of one substance made of a certain type of atom. We have the periodic table of elements, as we see here. All right. And a compound is a substance formed by the chemical combination of two or more elements in definite proportions. So what does this mean, right? We have a compound which is two or more elements. So two elements from the periodic table right here. So we could have lithium and bromine to make lithium bromide. Okay, a compound made of two elements. Some of the more common compounds you may have heard of are dihydrogen monoxide, aka water. That looks like this down here. Another one could be ammonia, those smelly cleaning products that your mom uses in the kitchen to clean. Looks like this guy on a molecular structure. And salt, right? Everybody loves salt on their French fries from the calf. Sodium chloride, right? All these things are made up of two or more elements combined to make a compound. So we're going to start talking about chemical bonds here, which is going to be making compounds from different elements. Okay, and it's important just to remember from last video the three parts of an atom. We have the nucleus in here, in this sodium atom, which is made up of protons and neutrons. Okay, protons and neutrons, and floating around outside we have the electrons, and they form an electron cloud. All right. If you notice, electrons don't stack up on top of each other; they start to spread out. And I like to think of this like a pizza pie, right? If we have pepperoni in the pizza pie, we can only put two in the middle. So then we make a nice little circle around them. We may put 3, 4, 5, 6 more pieces of pepperoni around that. Can't fit any more. Then we got to fit even more outside. All right. So just like this pizza pie, as an atom gets bigger, it has more and more electrons, and they neatly stack up in circles around the middle, around these two initial pepperonis. Remember, life is all about pizza. All right. So when we start to make chemical bonds, what does the bonds is not the protons, not the neutrons, but the electrons. Okay, the electrons are responsible for making the bonds. And the specific electrons are called valence electrons. So a valence electron is any free electron which can form a chemical bond with another element. So in our pizza pie example, right, these pepperonis or electrons on the outermost ring are free usually, right? They're able to go and make a bond with an electron of another atom. Unlike these two pepperonis way in the middle, right? There's no way that they could get out. So if we look at our example of sodium here, right, we see we have electrons in this first ring, we have 2. In the second ring, or energy level, we have 6. And if you noticed, on this outermost ring, we only have 1 electron way up here. Okay, so this 1 electron, all the way up here, is the valence electron. It's the free electron, the outermost, which is going to make a bond. The two types of bonds we're going to make with these valence electrons are called ionic bonds and covalent bonds. And the first one we'll talk about is ionic bonds. Okay, an ionic bond is formed when one or more electrons are transferred from one atom to another. And another word I like to use instead of transferred is taken, okay, or take. One atom takes an electron from another. When these electrons are taken, the atoms become ions. And an ion is any atom that has a positive or negative charge. Okay, they are charged. If it is a positive charge, it is called a cation. If it has a negative charge, it is called an anion. And again, we're going to keep going with salt here, right? So we have sodium and we have chlorine, okay? And they're going to form an ionic bond. Remember, the valence electrons, or free electrons, are what makes the bond. So if you look at sodium here, it has one valence electron on its outside. If you look at chlorine here, it has 1, 2, 3, 4, 5, 6, 7 valence electrons, okay? And chlorine only has room for one more. So what do you know? These guys are going to become best friends. This guy needs to get rid of one. This guy wants one. They're going to form an ionic bond. So when this happens, this sodium ion is going to give up this electron, okay, which is going to be taken or transferred, right, taken by the chlorine ion. So since electrons have a negative charge and this chlorine just got an extra one, it becomes negative because it has an extra electron. And the sodium gave up an electron, got rid of a negative charge, so it becomes positive. What do we know about positives and negatives? They attract. So this positive is going to be attracted to this negative, and they're sewn together super tight because of their positive and negative. They're attracted towards each other, and it's going to be so hard to rip them apart. This attraction is what forms the ionic bond. This free electron, this valence electron, was taken by the chlorine. Sodium becomes the cation, and chlorine becomes the anion. All right, so the other type of bond is a covalent bond. All right, and where ionic is where an electron's taken, it's really aggressive, and there's lots of charges. A covalent bond is much nicer. Okay, a covalent bond is when electrons are shared by an atom, or two atoms, or elements, instead of being taken or transferred. And the perfect example of this is our good old friend dihydrogen monoxide, aka water, right? H2O. So water between the oxygen and the hydrogen forms a covalent bond, all right, where the electrons are shared. So we have hydrogen, which has an atomic number of 1, which means it has 1 proton, and it has 1 electron. And it's going to share this 1 electron right here with oxygen. Okay, this electron is going to hang out right in between the two. Oxygen needs 2 electrons, okay, because it only has 6 in its outermost shell, 6 valence. So again, that's why we have H2O. There's 2 hydrogens. To make that oxygen happy and give it all the electrons it needs, it's going to take another electron from a separate hydrogen atom and share it in the middle, okay? Again, covalent bonds are where the electrons are shared or they hang out in the middle. It's not like ionic, where this one atom would have taken an electron completely away. They share and they hang out in the middle, so hydrogen can have an electron friend and oxygen can have some electron friends. With covalent bonding, you could have different types of bonds, all right? You could have single, double, and triple bonds. So this bond here between oxygen and hydrogen is a single bond, all right? There's actually 2 electrons that are counted, 1 from hydrogen, 1 from oxygen. If we were to have a double bond, there would be 4 electrons. Okay? And if we were to have a triple bond, which is very rare, we would actually have 6 electrons involved. And right, that's easy to remember because there's 2 electrons per covalent bond. So for a single, 2, right? 2 divided by 2 equals 1. A double, 4 divided by 2 electrons per bond equals 2 bonds. And 6. We have 6 electrons total divided by 2 per bond gives us 3 bonds. Okay. So after we have these covalent bonds where the electrons are shared, we get what is called a molecule. So this would be 1 molecule of water, all right, H2O. So a molecule is the smallest unit of a compound we can have, which is usually the most basic elements combined to make that compound. And it's important to remember that when we talk about making new compounds from 2 or more elements, we completely change all the properties that those elements won't have. If we were to have just hydrogen gas, right? So if we have the hydrogen from the H2O of water, we would probably explode because hydrogen gas is highly flammable. Same thing if we go back to our ionic bonds here. If we were to just eat sodium, it actually catches on fire if you put sodium in water. So again, chlorine gas, completely poisonous. They used to use it as a weapon of war. You would choke to death. So if we were to have sodium or chlorine on its own, without being bonded together, we would die a painful death. But once you make an ionic bond and join them together, you have table salt, completely harmless. And that just shows that, right, when we make bonds between elements, we completely change the properties of the old elements to make a new compound. Definitely write that down. The last thing we'll talk about today are called van der Waals forces. And I like to think this is like a big German guy who invented these. Van der Waal. All right. And van der Waal forces are not bonds. It's super important to remember that. Okay. They happen with covalent bonding. All right. And they are not bonds. They are forces. Okay. Which create an attraction. Okay. So a van der Waals force is an attraction between two molecules of a compound. All right, it is not a bond though. And the way this happens, all right, is that when we have covalent bonding, we have some atoms like oxygen that are big and hungry and want the electrons, right? It took an electron from this hydrogen and an electron from this hydrogen. Electrons are negative, so since we have more electrons around the oxygen, it becomes slightly negative. And if we remember, this hydrogen only had one electron. And since that electron is being shared with oxygen now, it hangs out more over in here. This hydrogen becomes slightly positive since it doesn't see its electron as much. What happens when we have billions of water molecules lined up with each other? This positive of the hydrogen is going to line up with another oxygen that's slightly negative, right? Because positive and negative attract. And then this oxygen will again have two hydrogens, and this hydrogen might be positive. So again, because it's a positive, another water molecule is going to go like this with its negative oxygen. And we have hydrogen plus. All right, and this continues throughout the whole like tub of water that you have. All right, again, we're not making bonds here. It's just a force, right? It's a slight attraction between this oxygen, which is a little bit negative, and this hydrogen, which is a little bit positive. So that's it for tonight, kids. Go back, watch it a couple times till you get it. Make sure you have all the vocab. Make sure you have a good understanding, because we're going to start to play with chemical bonds in class, and it's going to be crucial that you know these. If you have a question, email me or tweet at me, Mr. Toad13. Peace out, kids, and see you tomorrow.